Okay, Beck, I've got the solution to your question here. So what I've done is I've got the question that you've written and drawn a graph so I can see what's going on. So this is your weights across here. Now what it's asking for is if top 5% is rejected, so it's this bit in here, the 5% up here that they don't want, and then down here they don't want the 10%. Oops, 10%. So if we think of this thing being a continuum from this end to this end, 95% of your data is up to there, and only 10% of your data is up to there. So you're going to have to do two questions. Okay, you've got to solve it twice, and it's using the inverse function on your calculator in the standard deviation area. So we've got to work out. We know that it's 95% of the data. So what we're trying to do is find the value down the bottom there. So on the calculator it will look hopefully similar to this. So go to your stats function, then go to, inside that go to normal distributions. Now you might have this window here or whatever, so go to normal, go to inverse normal because that's what we're trying to find. Leave the tail going to the left because that means we're coming from this way across. The area will be 0.95. The standard deviation in this one is 0.1. The mean is 2. And then come down, move your little cursor down to go execute, which is F1, and you'll get an answer of 2.16. So that means that for the first bit, the 5% of the bags being rejected is 2.16 kilograms. And now to do the other one, which is the other end there, all the numbers are still remembered in this. Go exit. Go back up here, so now we're looking at this bit here, which is 10% of our data. So that changes to 0.1, leave it as a decimal. Scroll down here and go execute, and you'll end up with 1.87. So you're looking at between, if the bags are rejected being too heavy and 10% of the bags rejected being too light, what range must be acceptable? So it's between 1.87 kilos all the way up to 2.16. Okay? So that's the answer to the first one. I actually haven't looked at the second one, so let's see how that goes, and I'll send this to you now so you know where it's going on. Cheers.